This is Cambridge IGCSE for chemistry paper 4 theory extended for February-March 2023, variant 2. Okay, question number 1. This question is about gases found in clean dry air and gases found in polluted air. Name one gas found in clean dry air without which contributes to global warming. There will be carbon dioxide gas, question B, state the percentage of nitrogen in clean dry air. That is 78%. Next, name the substance used to remove sulfur dioxide in flue gas desulfurization. That is calcium oxide. Next, nitrogen dioxide is formed in car engines. Name the equipment in a car exhaust that is used to remove the nitrogen dioxide formed in car engines. That is actually the catalytic converter. Okay, next, all gases diffuse. Choose from the list of the formula the gas which diffuses the most quickly. Draw a circle around your answer. Now, diffusion is influenced by several factors. One of them is the mass. The lighter the mass, the faster the diffusion rate. So out of all, you need to calculate all of them, like their masses. Carbon monoxide is 12 plus 16 makes it 28. Carbon dioxide is 12 plus 16 times 2 gets 44. Methane is 12 plus 4 makes 16. Nitrogen dioxide is 14 plus 16 times 2. That should make about 46. And then you have sulfur dioxide, which is 32 plus 16 times 2, 32 plus 32, which is 64. So the lightest gas out of all is methane gas, right? Methane gas. So why is this answer chosen? Because it has the lowest relative molecular mass. Okay, next. State one adverse effect of carbon monoxide on human health. It is toxic. Next, carbon dioxide is a reactant in photosynthesis. Name the two products of photosynthesis. That will be glucose and oxygen gas. And let's move on. Complete a dot and cross diagram for a molecule of carbon dioxide. Show the outer shell electrons only. Very simple. You have carbon and oxygen. Carbon is located in group 4, which means that it has 4 valence electrons. Oxygen is found in group 6, so it has 6 valence electrons. So to achieve stability, carbon must need 4 electrons to achieve stability, and then oxygen needs 2. At the same time, because they're sharing, it has to be a fair relationship. Carbon has to share 4, so there's no more electrons left after bonding. Oxygen, there's 4 more electrons left after bonding. So for this is the valence electron. This column is representing the need, or should I say the share, contribute for sharing. Then this column represents the non-bonding electrons. So which gives us 4 for carbon used for bonding, so 2 each. Then oxygen contributes 2 for sharing. Then the rest is 1, 2, 3, 4, 5, 6 non-bonding electrons for oxygen, each of them. Okay, another method is you can also do the line method since everyone here is undergone organic. So carbon dioxide is C double bond, 2 double bonds, OO. Then because 2 electrons used for bonding. Oops, my bad. I made a mistake. Sorry. Wait, did I? Yeah, I made a mistake, sorry. So left with 4 non-bonding electrons. My bad. Here, luckily, I double checked everything. In exam, please double check. So carbon shares 2 for sharing. Then oxygen shares 2 for sharing. Then left with 4 non-sharing. Okay. So next. Lithium, sodium, and potassium are group 1 elements. Name the type of bonding in these elements because these are metals. So there's metallic bonding in group 1. Next. Sodium reacts with cold water to form hydrogen gas and a solution of strong alkali. State the test for hydrogen gas. So this one will be lighted spleen, and then we get a pop sound. So just the pH solution, pH of a solution of a strong alkali. So 14. Name a substance which can be used to confirm the pH of a solution of a strong alkali. If you want the pH, you want a chemical substance, you couldn't use acid-base titration indicators. You need to use universal indicator. Next, write the symbol equation for the reaction between sodium and cold water. So, sodium is a solid, reacts with cold water, which is a liquid, that forms sodium hydroxide because this is a group 1 metal. Group 1 metal are also known as alkali metals. They form alkali. So aqueous solution, plus they form hydrogen gas as a result. So balance this equation, you get 2 sodium hydroxides, 2 water, So 4 hydrogen on both sides. And then 2 oxygens on both sides, and then 2 sodium on both sides. Next, state the name given to atoms of the same element with different neutron number. Those are isotopes. Next, complete the table to show the number of protons, neutrons, and electrons in the atom and ion of lithium shown. Now, lithium is element number 3. That means that they have 3 protons. Neutrons, just take the big number, the mass number minus proton number. So one is 3, one is 4. The last one, electron, look at the charge. Because this is an atom, no charge. Proton equals to electrons, so 3 electrons. For the one on the right, there's 2 electrons, so 1 more proton and electron. That makes it a positive 1 charge. Okay, next. Table 2.2 shows the relative abundance of 2 naturally occurring atoms of lithium. Calculate the relative atomic mass of lithium to 1 decimal place. So simply just take, this one is actually similar to mathematics, mean mass. So to find average, we just take the frequency multiplied by the object divided by total frequency. But regardless, if you're talking about chemistry, in the context of this question, we will have to multiply the abundances, so with the masses, and sum them together. So 7 times 90 divided by a total of 100, because 100% is total abundance. That makes it 6.9. 6.9. Okay, next question. Potassium oxide is an ionic compound. Complete the figure to show the electronic configuration of the ions in potassium oxide. Show the charges on the ions. So potassium is group 1, form +1, so positive. Oxygen is group 6. Group 6 forms -2. It will take 2 electrons, 1 each from potassium. So it would have, because it's group 6, it has 6 electrons. But 2, it will take it from the potassiums. Okay, so 3 marks essentially awarded to the charges and awarded to the shell with electrons. And then with the, of course, with the correct symbol, crosses, 6 crosses, 2 dots. Okay, next question. Pause. Overlook one thing. I overlook one thing, which is potassium is a period 4 element. Period 4 element, which means that after giving out 1 electron, it would have 3 shells filled with electrons left. 3 shells filled with electron left. So it would be, we need to draw the outer shell electron for potassium. Okay, next question. Next, the Haber process is used to manufacture ammonia. State the main source of each gas used in Haber process. Nitrogen is gathered by fractional distillation of liquid air. Hydrogen is gathered by methane, or you can say it comes from natural gas. Okay. Next, the equation for the Haber process is shown. The reaction is reversible. The forward reaction is exothermic. State what is meant by the symbol delta H. So it's enthalpy change. The delta H for the forward reaction is negative 92 kilojoule per mole. Think why this value shows that the forward reaction is exothermic, because it has a negative symbol. Okay, state the typical conditions and name the catalyst used in Haber process. 450 degrees Celsius, 200 atm, also known as 20,000 kPa. Catalyst is iron as a catalyst. Next, complete the table to show the effect, if any, when the typical conditions in the Haber process are changed. Use only the words increases, decreases, or no change. So first of all, you have to do the rate first. I will suggest my students always do the rate first because it's easier, because these are two different concepts. Now, when rate increases, as we know, as pressure decreases, rate should decreases. Rate should decrease. On the other side, effect on the concentration of ammonia equilibrium. So look at the product here. Increased temperature favor the endothermic reaction, in which, because the forward reaction is exothermic, the backward reaction is endothermic, so it will favor the backward reaction, means the equilibrium position shift to the left. It will decrease the concentration of ammonia at equilibrium. Next, pressure decreases. So when pressure decreases, it will favor the side with more gas, which is on the left. Same thing, it will favor the backward reaction. No catalyst, no change. All right, it will not change yield. Catalyst will not change yield. Explain in terms of collision theory why increasing the temperature increases the rate of this reaction. So this is due to that increased temperature, increased rate of reaction. Okay, so first of all, it increases the kinetic energy of particles. Kinetic energy of particles, which means that they move faster. Particles move faster. So the frequency of collision increases. Plus, there's a higher fraction of particles possessing energy greater or equal to the activation energy. So which means that the frequency of successful collision will increase. Next, state the formula of the acid used to make ammonium sulfate. So to make a sulfate salt, we need a sulfuric acid. Formula is H2SO4. State one use of ammonium sulfate as a fertilizer because it has nitrogen. Remember NPK fertilizers. Nitrogen is a very good fertilizer. Next, calculate the percentage composition by mass of nitrogen in NH42SO4. So simply, percentage composition by mass is simply taking the nitrogen mass over the total mass multiplied by 100%. So mass of nitrogen, there's two nitrogens here, so 2 times 40. Total mass, you have to use your periodic table. Essentially, it is 2 sets of ammonium plus sulfur plus oxygen. So 2 times 28 plus 32 plus 16 times 4. Allow me to punch these numbers into my calculator. 2 times 28 plus 32 plus 16 times 4. You get 152. So 28 out of 152 times 100% makes a grand total of 21.2%. 21.2%. Okay, next. Brass contains copper. Name the other metal in brass, zinc. State the term given to a mixture of a metal with another element that is an alloy. Copper can be stretched into wires. Copper wires conduct electricity. Name the property of metals, which means that they can be stretched into wires, as well as ductility. Name the particles responsible for the conduction of electricity in solid copper. These are metal, so they have free moving electrons. Next. Copper is a transition element. Some physical and chemical properties of transition elements are shown. High density, high strength, form colored compounds, have ions with variable oxidation numbers. State one other physical properties of transition elements. Physical property of transition elements include, well, high melting point and boiling point, but usually we just refer to melting point. Then state one other chemical property of transition elements, so they are able to act as catalysts. Next, state the term given to water molecules present in hydrated crystals. That will be water of crystallization. State the color of hydrated copper 2 sulfate, that is blue. Write the formula of hydrated copper 2 sulfate. So CuSO4 dot 5H2O. Okay, each copper 2 sulfate is surrounded by 5 water. Next, copper 2 oxide is formed when copper 2 nitrate is heated. State the class of oxide in which copper 2 oxide belongs. Because it's a metal oxide, we should expect it to be a basic oxide. Say the meaning of the Roman numeral 2 in the name of copper 2 oxide. There will be the oxidation number, also known as the oxidation state, is 2 for copper. Next, 0.02 moles of copper 2 nitrate is heated. Calculate the mass of 0.02 moles of copper 2 nitrate. So we have to find mass from moles, we need to take the moles divided by the molar mass. Wait, sorry. Moles multiplied by molar mass, right? Moles multiplied by molar mass of this particular substance. So we need to find out the moles. I mean, no, not find out, but take the value here. Then we have to calculate the molar mass of copper 2 nitrate. Take it from your period table. 64 for copper. Then we have 2 sets of nitrate. 2 sets of nitrate. So 14 plus 3 times 16. So a total of 48 plus 14. That makes it a 62. 62 times 2 is 124. 124 plus 64 is 188. That makes it 3.76 grams. Next, calculate the total volume of gas in cubic decimeters produced when 0.02 moles of this particular substance is heated. Okay, so if you look at the equation, from the equation, every 2 moles of copper 2 nitrate heated will form 5 moles of gas in total. It's a 2 to 5 ratio. The mole ratio is a 2 to 5 ratio for this and this. 2 to 5 ratio. So if you use 0.02 moles, they will make 0.05 moles. So 0.05 moles of gases will occupy, regardless of type. Each mole occupies 24, so 0.05 occupies 1.2 cubic decimeters. Next, powdered aluminium reduces copper 2 oxide. Write the simple equation for this fraction. So aluminium reacts with copper 2 oxide by reducing it. So you will form aluminium oxide and copper remaining. This is a displacement reaction. I have 2 aluminiums. 2 aluminiums, 3 copper, 3 oxygen. Okay. Next, propane, propene, and propane 1-ol and propanoic acid are members of different homologous series. Molecules of these substances contain 3 carbon atoms. Explain why members of a homologous series have similar chemical properties. So similar chemical properties is due to the same number of valence electron. Sorry. No. Sorry, my bad. Habit. It has been a habit. When I see this word, I think of same number of valence electron. No. That's for the same group. That's for the same isotope. This is for homologous series. Why do they have similar chemical properties? Because of the, allow me to pick up my pen just fell. Okay. Why do they have similar chemical properties? Because they have the same functional group. Name the homologous series to which propanoic acid belongs. That belongs to the carboxylic acid homologous series. Take the general formula for the homologous series to which propanoic acid belongs. So CnH2n plus 1 COOH. That's the general formula for carboxylic acid. Propane 1-O has an unbranched isomer. Name this isomer. There will be propane 2-O. Okay, shift the functional group. So how to draw this particular formula of this isomer? It is a 3-carbon alcohol. So it is an alcohol, so that it has a OH functional group located at carbon 2. Then fill in the rest with hydrogen. Next, propylene and propylene can be manufactured by heating the cane in the presence of catalysts. One other product is formed. Complete the equation for this reaction. So it forms propane, which is C3H8, forms propene, which is C3H6. What's the remainder? We get 4 carbon left and then 8 hydrogen left. Name this manufacturing process. It's known as cracking. Next, propene forms a polymer named polypropylene. Draw the display formula of a section of polypropylene showing 3 repeating units. Okay, so you need to know propene, which is a 3-carbon alkene. It undergoes addition polymerization using this as your building block. Okay, when addition polymerization occurs, it's an alkene, so it undergoes addition polymerization. The double bond will be turned into 2 extra single bonds. And then what you need to do is just repeat 3 times. Because it asks you to draw 3 repeating units. So 1, 2, 3. Okay. So next, what is the type of polymerization for alkenes? Alkenes, think of addition. When you see the word addition, think of alkenes. When you see the word alkenes, think of addition. Propanoic acid reacts with aqueous sodium carbonate to form a salt. Suggest the name of the salt form. So, well, it forms sodium propanoate. Sodium propanoate. What is the formula of the anion of this salt? Okay, to know propanoate. Propanoate is, okay, start with propanoic acid first. It is C2H5COOH. Right, C2H5, yeah, C2H5COOH. It is a carboxylic acid, which means that it's a weak acid. It will form C2H5COO minus and a hydrogen ion, partially dissociates. So this is called the propanoate ion. So C2H5COO minus. Next, propanoic acid forms an ester when it reacts with ethanol in the presence of catalyst. Suggest a suitable catalyst. So this one will be an acid catalyst. Esterification requires an acid catalyst. You can use, example, phosphoric acid as a catalyst. Name the ester form. So it is alcohol first name, carboxylic second name, ethyl propanoate. Draw the displayed formula. Simply just take 2 carbon for ethyl, 3 carbon for propanoate. Propanoate is C double bond O, is an ester group, C double bond O, single bond O. Then fill in the rest with hydrogen. I mean, make sure all carbon has 4 lines. Then you're done. Okay, that's pretty much it. Let me double check C2H5, ethyl, and propanoate. Okay, that's it for this video. Thank you for watching. If you'd like to see more, you can subscribe. All right, or click a like or send a comment. And I'll see you in the next one. Bye bye.